All right, guys, so now this is video 2 for that March 31st, and I had asked you at the end of the last video to draw in the triangles, okay? And if your little and medium are opposite of each other, that's fine. I just realized that in my world, this looked like the little, and then this looked like the medium. But if you said this was the little and the other guy was the medium, that's fine. It really is. It's just making sure you have the 3 correct triangles. Okay? Now, this time I said I want to solve for x and I want to solve for y because there was 2 variables out there, the x and the y. So if you want to do the x, your focus is take the 2 triangles that have 2 sides at least labeled, but they both involve x's. Because all 3 of these triangles have 2 sides labeled at least. The blue one even has 3 sides. But if I try to use the green triangle to solve for x, that won't help me. Because there's a 10 and a y. And I have no idea who y is, so I don't want that. So for the solve for x one, I would use that piece and that piece. By the way, I should probably put in my right angles because that would really help me when I start labeling things. When I solve for x, I'm going to do x over 2. And in my visualness, I think that's long over short. And then I'm going to solve over here. I need long over short. I'm not using the y because that's the hypotenuse. So I'm going to have 8 over x. Okay? And from that, you can cross multiply, square root, x is 4. Okay? Now, especially since I did not draw this one that well, because it was hard to see who's short, who's medium, what's the long side, what's the short side, I want you to stare at these problems that we've done so far and look at how the x's, one's on top and one's on bottom. And if you look back at our other pages, take a notice, I'll highlight them. On our different problems that we've done, there's an x, there's an x. One on top, one on bottom. One on top, one on bottom. Here, I don't have pairs of x's, but I have an 8 and an 8. An 8 on bottom, an 8 on top. An x on top, an x on bottom. It will always happen that a pair of symbols, if they're both x's or if they're both 8s or whatever the case may be, one will be on top and on the other fraction it will be on bottom. That's always a nice kind of hint to make sure you are setting it up correctly. So on this y1, without even solving it yet, there's going to be a part where you can have a y on top and then a y on bottom. Okay, and I'm going to show you that here in a second. So if I'm solving for the y1, I will circle these in yellow. Oh, that meant red. Let me do an undo there and do yellow. There we go. I'm going to use that one because it has a y. I'm going to use that one because it has a y. Okay? Now, don't use the x because I don't have an x on that green triangle. I have an 8 and I have the y. So I'm going to do something like this. Y over 8. Now in that case, y was the hypotenuse and 8 was the long. So I have the hypotenuse over long. So I better do the same on the green guy. The hypotenuse is definitely 10. And again, it's hard to see that that y happens to be the long side. But with my little hint, you should also see that one y is on top, one y is on bottom. You probably set it up correctly. Okay? From that, you can cross multiply and solve. 80 equals y squared, square root of it. Y equals square root of 80. That is not nice. Okay? Square root of 81 is nice, but square root of 80 is ugly. So for right now, I might be teaching you later how to reduce that radical. But for right now, I'll just say that's good enough. Okay? Because it doesn't go in perfectly, so let's just call it the square root of 80. Okay. So 1 on top, 1 on bottom. And I'll highlight one more time just so you can see it because that's going to help us on the next page. 1 top, 1 bottom for the pairing. Okay? Couple new vocab words for you. Arithmetic mean is something you've grown up with for a long time, since probably like 5th grade, 4th grade. How do you find an average? You add them up and divide by how many you have. Okay? So an arithmetic mean, the whole key is adding up. So if I ask you for the arithmetic mean of 2 and 10, you would just go 2 plus 10 equals 12, divided by 2 equals 6. That is the arithmetic mean. That means that if you got a 6 on the first test and a 6 on the next test, that would have been the same as getting a 2 and a 10. Okay? An arithmetic mean, you could have done something like a 3 and 7. And 3 plus 7 equals 10, divided by 2 is 5. That means if you got 2 5s, that's the same as a 3 and a 7. And that's kind of a duh. We've done arithmetic mean for a long time. Arithmetic, key part, add. And so you're adding things up. Okay? And then once you add things up, you then divide out by how many you had. So I divided it out by the 2. Okay? Now, the new one for the day, since you're in geometry, I thought you should probably learn something called a geometric mean. This is a little bit different than arithmetic. Arithmetic is all about adding up. Arithmetic is saying 3 plus 7 is 10. What number could you add up twice to get the same sum? And you could have done 5 plus 5. Well, geometric mean is saying this. You multiply them up and then square root it. And I'll show you an example, and then you'll go, oh, okay, I kind of see what you're saying. A question could be this. Find the geometric mean of 4 and 9. Now, what this is saying is what number times itself is the same as if you did 4 times 9. So in this little statement, I guess I should do 4 times 9 equals 36. Square root it is 6. That is my geometric mean. Why? Why is that my geometric mean? Because 6 times 6 is the same as the 36 that you just had. Okay, so 4 and 9, the geometric mean of that is 6, because 4 times 9 is 36, and 6 times 6 is 36. You could do another one, and you could do something like, let's do 4 and 16. So what times itself is the same as doing 4 times 16? So the way you get this is 4 times 16 equals 64. Square root it, 8. That's your geometric mean. And the reason is because 8 times 8 is the same as 4 times 16. Now, this geometric mean has happened all day long so far in our examples with the right triangles. Because what you've noticed in a lot of those right triangles is you might have had something like this. X over 27 equaled 3 over x. You had that once, or something like that. And this is the way you can set up. You can solve for a geometric mean this way, because when you look at this, if I cross multiply, I got x squared equals 27 times 3. X squared equals 81. Square root of 81, x equals 9. So what this is rephrased is, you could have said this. What is the geometric mean of 3 and 27? Well, the way you would have done that is you would have gone 3 times 27 equals 81, and the square root of 81 is 9, and that's your geometric mean. Okay? That is the exact same way as solving this proportion. So on all of those right triangle guys, when I ask for the geometric mean, you're doing it with that right triangle, because when you set up that proportion, you're getting an x on top and an x on bottom, and that's saying when you cross multiply, x times x equals that 81. So that's the idea of the geometric mean. When I come back tomorrow, I can talk a little bit more about the application of the geometric mean, but I just want today you to see the relationship and how to solve it for some of your homework problems. Okay? So the key, again, geometric mean, is you're going to have x over a number equals some number over x, and you can solve. Now, we've already done the 4 and 9, but just so you can see it, instead of doing it as 4 times 9 and square root it, write it as, if the question says find this geometric mean, I'd go x over 4 equals 9 over x. Or you could have done 4 over x equals x over 9. It doesn't matter, because when you cross multiply, you're going to get x squared equals 36, x equals 6. Okay? Here, if I have a 12 and 4, I'd go 12 over x, since x is on bottom, x goes on top. Cross multiply, I get 48 equals x squared. Square root it. That's not a nice guy, and so again, for today, let's just leave it as the square root of 48. So those are types of homework questions tonight. You don't really know the application of geometric mean yet, but I'll kind of show that tomorrow. Okay? Okay, the next part of today is actually 7.5. So I'm doing 2 sections today because in my opinion, they're pretty easy, okay? Or at least 7.5 is easy versus 7.4, you need to take some time when you're drawing those 3 right triangles, the middle, the small, and the big, okay? So there are 2 types of things today on 7.5. One's called side splitters and one's called angle splitters. Okay, side splitters. Key thing, you need parallel lines. So for this example that I want you to copy down in your notes, you got parallel lines. Okay? So with that, and if you're thinking this has to be a mid-segment, it doesn't. Okay? That line here can go anywhere as long as it's parallel. Okay? So it's right there, and you can tell it's not a mid-segment because the 3 and 9 aren't equals of each other. But here's the nice thing. What this is saying is, I'll kind of draw it. This yellow triangle is going to be similar to this big blue triangle. That yellow turned green now. So the blue triangle is similar to the red triangle. Or sorry, the blue triangle is similar to the yellow triangle. Blue is similar to the yellow. If that's the case, then we can say one thing is proportional to the other thing. Okay? I'm excluding the proof of why the 2 triangles are equal, but a quick reason why is since there's parallels, that angle equals that angle, and this angle will equal this angle, and so on. Those 2 triangles are similar by that AAA similarity proof. Okay? Wow, that was quick and easy. So, if they're similar, you just get a set of proportions. So because they're similar by AA, we can just do x over 12 equals 3 over 9. Okay? Left over left part equals right over right part. Okay? And you can cross multiply. Okay? I got x is 4. Now you might not like the way I solved it, because if I told you one triangle is proportional to another triangle, is that 12 really a whole length of that triangle? Because take a look at this. That 12 that I just did is only that part. So normally when you do ratios, you do a whole length over a whole length. If you want to, you could do this. Let's try this a different way. x over, what would the whole length over here be? The whole length, not just the x, but the x and the 12. You could say that whole length is x, and x plus 12. And on the right side, you could say 3, which is the small side, over what's his whole length? The whole length of this blue triangle is a 3 and a 9, which is a 12. Now, you could solve the black one, or you could solve the blue one. Okay? If I solve the blue one, I want to show you that it's going to be the same. I got 12x equals 3x plus 12s. 12x equals, remember to distribute, 3x plus 36. 9x equals 36. X equals 4. Which guy had less work? The blue version or the black version? I think the black one. So what's nice is you can do a little piece over a little piece equals a little piece over a little piece. So let's take a look at this example. Okay. So I have parallel lines. Those are my little green birds. And I have a top triangle, and then I have the whole triangle. So again, you can think in your mind that yellow triangle is proportional or similar to the blue triangle. Okay? So when you solve, though, I think we're starting to learn just from that last example. Since they're similar, and why are they similar? A. Okay? You can do top left over bottom left equals top right over bottom right. And you can solve. So now I got 40 equals 8x. X equals 5. Okay? Yes, the other way you could have solved this, as you've kind of started to realize through all of the problems today, kind of like the warm-up problems, there's multiple ways to solve. If you want, you can do little over all needs to equal little over all. And if you're going, where in the world did those bottoms come from? Realize that I did little 2 over all of the length, which is x plus 2, over little 8 over all of that length. And if you do that, I promise you when you solve that, you also get x equals 5. Okay? Now, when you have one, don't just get super giddy and go, oh, all the time I can solve these things. So I made this one very clearly non-parallel. But do not get in the fact that you're trying to go, oh, x over 10 equals 15 over 3. You can't do that because it's not parallel. So, tricky Bach, knowing that I am, I could give you a problem once, and I could have it like this. Give you an x and a 5 and a 2 and a 10, and just say, hey, solve for x if you can. So I'd give you a problem and say, solve for x if you can. What's going to happen is half of you are going to do this. Oh yeah, I got this. X over 5 equals 2 over 10. Let's see, 10x equals 10, x equals 1. Woo! Easy. Turn in, problem, done. You're wrong. Because right now, these look parallel, but they aren't officially parallel. So since you don't know if those are parallel, you have no idea if this angle equals that angle. You have no idea if this angle equals that angle. Since you don't know anything about the angles, do you know anything about them being similar triangles? No. So here you need to say, I can't solve. This way's wrong, and you'd say can't solve. The thing that you're missing, the thing that you need to solve any of these problems are the parallels. Okay? We're going to do another example, and then we're also going to finish up with one extra type from 7.5 on the next video.